This is the solution to problems number 5 and 6 from Worksheet 2.5 version 2, Translations and Transformations. At the top of the screen, you'll see I've copied over the critical points from the previous slide. So we have x and f of x values -4, 0, -3, 1, etc. So we're going to use that in a little bit. We're going to begin here by looking at the transform function. And we have f of 1/2 x minus 1. In this case, we need to be careful because we have both a horizontal stretch and a shift. So we're going to begin by factoring out the coefficient of x. So we have to factor out the 1/2. When we do that, we're going to have f of the 1/2 x minus 2, and you can check that by distributing the 1/2 back in. So if I distributed the 1/2 back in, I'd have 1/2 x minus 1/2 times -2, which would be -1, which is what we started with. So this is a better version of m of x to work with, so we can see the transformations that are going on. So we have two things that are happening here. We have the 1/2. So this 1/2, that corresponds to a horizontal stretch by a factor of 2. Remember, whatever we do to x is the inverse of what we see. So if we see x multiplied by 1/2, that really means we're going to have a horizontal stretch by a factor of 2. And in terms of what we're going to do to x values, I'm going to start summarizing them down here. We're going to multiply x's by 2. The second transformation that we have is we have a -2 inside the function. That means it affects x. This transformation is a shift right 2. And what that means, what we're going to do to every x value is we are going to add 2 to our x values. There's no transformations outside the function, so we don't do anything to y. So no changes. And now we're going to perform these transformations on the critical values. So we're going to get our new points, x and m of x. So we're going to start, so I'm going to take each x value, multiply by 2, and then add 2. So -4 times 2 is -8, plus 2 is -6. The y values stay the same, so 0. -3 times 2 is -6, plus 2 is -4. The corresponding y value is up here, which is 1. We're going to go to the next x value, which is -2. -2 times 2 is -4, plus 2 is -2. And the corresponding y value there is 1. The next value is -1. -1 times 2 is -2, plus 2 is 0. The corresponding y value is this one, which is 3. We have 2 left to do. We're going to be at 1. So when x is 1, 1 times 2 is 2, plus 2 is 4. Corresponding y value is -1. And we had the last value, x is 2, 2 times 2 is 4, plus 2 is 6. And the corresponding y value is 1. And now we're going to plot these. I guess I'll plot them in blue. So I'm going to plot these values, -6, 0. You can see I already plotted f of x to save a little time. -4, 1. -2, 1. 0, 3, 4, -1, and 6, 1. And then I'm going to connect these line segments to get our transform function, which is m of x. Let's move over to problem number 6. Once again, we're going to use the same critical values as we did in the previous function, because we're starting with the same parent function, f of x, which I've graphed already on the grid. And then we're going to look at the transformations. So what transformations we see in this function, we're going to list those and then say, what do we do to x and y? And I've started with a little template here for us to work with. So this -2 out in the front, it may be easier for you to just think of it as -2 at the end. If that's easier, you can rewrite it. So that -2, what that does is it's a shift of y down 2. And the next thing that we're doing to y is, I'll do this one, the 3. the 3 is a vertical stretch by a factor of 3, which means we're going to multiply y by 3, and I didn't write this down too. It means we're going to subtract 2 from y. And when we perform transformations, always do things that involve multiplication. So those are reflections, stretches, and shrinks, before those that involve addition, which will be translations or shifts. So this translation is another word for shift. So in terms of x values, we are going to be, in terms of y values, we're going to be multiplying them by 3, and then we're going to be subtracting 2 from them. X values, we can see what we change on x by looking inside the function. So what do we have inside the function? X has been replaced with x plus 1. That corresponds to a shift left by 1. Remember, whatever we see being done to x, we actually do the inverse. So that means we're going to subtract 1 from x. So I'm going to put that down in my little summary unit here. So I'm going to do x values minus 1. Then we will perform these transformations on the key points. So I'm going to do all the x values first. So each one of these x values, I'm going to subtract 1. So negative 4 minus 1 is negative 5. Negative 3 minus 1 is negative 4. Negative 2 minus 1 is negative 3. Negative 1 minus 1, negative 2. 1 minus 1 is 0. 2 minus 1 is 1. Those are all our x values. Y values, we're going to multiply by 3 and subtract 2. So 0 times 3 is 0, minus 2 is negative 2. 1 times 3 is 3, minus 2 is 1. Same value, we had 1. So 1 times 3 is 3, minus 2 is 1. Then we have 3. 3 times 3 is 9, minus 2 is 7. And then negative 1 times 3 is negative 3, minus 2 is negative 5. And finally, we have 1 again. So 1 times 3 is 3, minus 2 is 1. So those are our coordinates. And then we can go ahead and plot those to get the transform function. So negative 5, negative 2, negative 4, positive 1, negative 3, positive 1, negative 2, up at 7, and 0, negative 5, and 1, 1. And then we can connect those to get our transformed function. So this is what was called y for us, or the transform function.